Am I audible? Am I audible?
Hello, can you hear me? Hello everyone. So welcome to session 4 of School Control Electronics Club. In this session, we are going to be looking at how we can incorporate all the knowledge that we gained in the past three sessions in order to make a simulation of each lab. So let's begin. Project consists of two parts. One is a tracker and the tracker we are going to be the physical hardware uses a receiver that access the microcontroller and the battery, whereas the receiver uses lower receiver and a microcontroller and a LED display. So this is just the physical hardware, but when taking it hardware making the physical component of making use. This is a flowchart of how the computer works. So it was starts with processing the moment detection which is done by the accelerometer, and once after the initiation process, microcontroller checking if the movement has happened or not, or the accelerating or not, and it detects movement microcontroller, and after the microcontroller, the GPS gives the location or the coordinates of target or the tracker, and then it will send it to the receiver end. And so on the tracking loop keeps on going, and this ensures continuous tracking. Uh, keeps on checking once it doesn't detect it just and the MCU once again goes back into the sleep state. Okay, so from here we are going to be setting up the transmitter circuit in Walkme. And
So hi guys, am I audible? Voice is not breaking, no? So okay, first we start with setting up the OQ simulation. I'll screen share. Okay, are you guys ready with your laptops? First, go to OQ simulation, and then we are actually ESP32. So select ESP32 section, the first one only. Yeah. Uh, what I want you to do is first remove everything. We'll start new. Wait, wait. Is my voice uh, audible? Is it not breaking? Hello? Okay. Is my voice audible right now? Can you guys react? It's fine. No, not breaking. Yeah. Okay. We will start with the walkway simulation part. Uh, as we were seeing, I'll screen share. Yeah. Should I explain this again? How to set up? Okay, I will explain. Uh, First, go to oakweed.com and then select ESP32, and then we need a starter template, that is ESP32. We can go and we can see sketch.ino and diagram.json and a library manager. These are important. For this one, we will delete all .ino. We'll write the code by star. So what we need is another accelerometer, that is MPU 6050 accelerometer plus gyroscope. We'll add this, and now for the part of connections. Okay. uh, See, you can see VCC, ground, SCL, SDA, and we don't need XDA, XCL, and AD0. We'll start with connections. First, we have to connect 3v3. 3v3 stands for 3.3 volt. This goes to VCC of the sensor. Okay, and now we can connect a ground Uh, did you guys connect it? Yeah. Next, we'll move on. And there are two types of pins. One is SDA and another one is SCL. SDA stands for serial data pin, and SDL stands for serial clock. What you have to do is connect SCL to 22nd pin. Okay? And then SDA to 21st pin. Okay. These are the only connections we need, and now we will start with the coding part. The connections are made, but we have to set up these connections. Okay. First, we have to add certain libraries. For example, okay, we'll add Adafruit MPU 6050 and Adafruit unified sensor and Adafruit bus IO. Okay. Did you guys add it? Yeah, we have to go to the library manager and add plus here. You can add these. Okay, I think you all added. I will go on with the coding part. Okay. Uh, first, first we have to include all the libraries we have just added. That is include and the library name. Uh, One is Arduino.h and wire dot h and we have to include the libraries we just added. Okay. I will briefly explain what. I will briefly explain what all these libraries do. Arduino.h gives basic Arduino functions like setup function, loop function, and serial print and delay function. And wire.h enables I2C communications that has ESP32 talk to any sensors. For example, here we will uh, talk from ESP32 to the accelerometer. And what ADF fruit sensor does, it provides a common sensor interface. I will show you the interface afterwards. And adapt fruit, this gives us functions like MPU begin, MPU dot set, accelerometer range, and get event. Okay, we will explain that now. Okay, we will start. Okay, uh, this line is creating the sensor object. This creates an object that is called MPU. Think of it like creating a remote control for the MPU 6050. Using this object, we can do things like initializing the sensor, change sensitivity, read the acceleration, and read gyroscope values. Example: MPU.begin starts the sensor, and MPU.get events gets the data. So, okay, from this we are creating an object that is called MPO. Did you guys get it? Okay. Are you guys familiar with C++? Okay. C++ mainly includes, first we have to include all the libraries we are doing. There are some certain functions which are library. For example, we can create a shortcut for the functions, and I will explain the basic thing. There are variables, and you have to give it values. For example, uh, consider variable x, int x equal to 5. This is a valid equation. We are assigning value of 5 to the integer x. So like that only, we will create some variables. First, we'll create constant float. Float is like a number which can have decimal also, but int is integer. Float can have any value. So we create. Okay. Uh, First, we will create a motion threshold named variable, which is a constant variable, which is 0.35. Why we have to create a motion threshold is when the sensor is when there is a motion detected in sensor, that the motion should be crossing the threshold value, or else the okay guys. Okay, I'll start it again. I will explain the motion threshold value. What is motion threshold? Uh, we have to create some threshold value. If the total magnitude of the acceleration is below the threshold value, we don't give a command change the coordinates, because that can be any noise also. Due to some noise also, uh, the, the value can change. We will explain values. Okay, we will create an interval, tracking interval. What would you mean by 10,000? Here 10,000. Here 1,000 value tracking interval is 1 second. So here 10,000 is 10 seconds. I will 10 10 10 second. And another stop cooldown equal to 2000 means 2 seconds. If the cooldown of the stop, the motion, if the motion detection is stopped, then that cooldown will be 2 seconds. After that, the sensor will go to sleep mode, low power sleep mode. Then we will explain state machine variable. We will define uh, boolean. Do you guys know what is boolean? Yeah, a variable which can contain only true or false state. Okay, we'll define two booleans here. One is moving. Okay. First for initial, we have to initialize a variable always. Uh, we will give a false statement, but because when the sensor starts, initially it will be not moving, so we create is moving boolean, and then we'll create another one. Okay, we'll create another one, tracking active, which is also will initialize it as false only. Okay, why do we need these two booleans are uh, when when the sensors are when the sensors are active, uh, we have to see it is moving or it is stationary, and is the tracking live or the tracking is off. Next, we'll go with and we'll Uh, I think, guys, I will explain it again. The explanation was not up to the mark. Okay. These are the header files. These are we including all the libraries. These libraries give our program extra capabilities such as Arduino Edge gives basic Arduino functions like setup, loop, serial print, and delay. And wire.h gives enables I2C communication. The ESP32 uses this to talk to the motion sensor, and Arduino sensor.h gives a common sensor interface, and MPU6050.h contains all functions required to communicate with the MPU6050 accelerometer. And next, we have to create an object. We have created object here. Think of it like in creating a remote control for the MPU6050. We this object can do things like it can change any sensitivity or and initialize the sensor and read the acceleration and gyroscope values. Uh, and next we have to do system configuration. Uh, these are the system configuration lines. We have created a float that is a variable, and means constant variables are cannot be changed, so the value is fixed throughout the code. So what is motion threshold? If the acceleration changes by more than 0.53 meter per second from normal gravity, the device is considered moving. Smaller changes are ignored as noise, so it has to cross 0.35 threshold value. And other we are creating an unsigned long means a long is also variable and but an integer type. The tracking interval is 10 seconds. After every individual 10 seconds, the tracking is done. It gets the value and computes it. Another constant log stop cooldown. Device must remain still for 2 seconds. Then only it is considered as it is not moving. This prevents false stopping because of any tiny vibrations. And we will explain state variables. Uh, these variables remember the current state. For example, uh, it is moving. It is moving or not, and tracking is active or not. So initial moving is off, so that's why false, and initial tracking is also off, so that's why false. And after that, these are the timer variables. Unsigned long are these stores timestamps. Instead of continuously sending GPS, remember when was GPS last was sent? When was last GPS was sent? Similarly, and when was the last motion was detected? So these two are initialized to zero currently, and then it moves on changing. Okay. Next, we will create a baseline gravity. Okay. Wait a second. Next, we will create a baseline gravity. This one also, which will give a value of 9.81, always in meter per second square. Okay. The downward gravity is 9.81. It measures this gravity, so our program compares the measured acceleration with 9.81. If it changes significantly, the object is moving. Next, we will create mock GPS coordinate. Because walkway simulation does not have a dedicated GPU module, so we will initialize GPS coordinates and change the GPS coordinates according to the motion detected here. Okay. We will give a random value, 13.0827 or something. Okay. We'll give a random latitude and random value of longitude. Okay. Uh, okay. What does the code do? After during movement, the code slightly changes these numbers, making it look like the device is traveling. This allows testing without needing satellites. Uh, did you guys understand everything? Do you guys have any doubt in these any lines? You can put your own values, but me and Deepak are using the same values, so we put this one only. These are just all the we are just defining the constants. These are used in next setup and loop functions. So from now on, Deepak will carry on.
Hello guys, yeah, so can you hear me? Okay, so I think we finished up setting up all the libraries and the variables. So next we'll move on to the setup block and the loop block. So this will be the setup. This is mainly used for initialize function and it runs exactly once. So code and also initializes the communication protocols for the I2C communication. So what we're going to do is we're going to start off with serial. So we are going to be expectation channel between the uh, simulator and 200. This is a standard boundary, so we're going to be using this. Okay, so this block which essentially set it up, we would have to do uh, something so that it would prop it up and prevent any errors from occurring. Next, you're going to be using this print function to display that the simulation has actually started. Okay, so actually the exclamation mark indicates that it's a negative, so which means if it doesn't happen, then we have to delay by 10. you're going to initialize the I2C communication by setting up GPIO of 22. So for that, we are going to be using. Okay, so here we are using a if function to check if it has actually done. So we write an mark mpu.begin. This essentially tells it that mpu.begin checks if it has actually been set up. So if it has not been set up, that is if it is false, then we display that the MPU sensor was not found. Okay, so next we use this line to actually tell it that if it is not detected, then we delay it and we display an error. So we, if this if loop was not executed, then use the serial.print function to display this statement successfully. Then now we are going to be setting the acceleration range so that we will have some realistic values. Okay, so using this, we have set the the range of the accelerometer up to plus minus 2g. You could set it to plus minus g also, but 2g would simulate a real life situation and with realistic values. Okay, so essentially we have set up the microcontroller. So and it would be entering low cost state. So we just put in that. Okay, so essentially after this, you finish setting up the while loop. I just missed an indentation over here. And that should be fine now. Okay. Okay, so after setting up the while loop, we'll be setting up the loop block. While okay, so this block would be running uh, many that is this would be responsible for making sure that the sensor keeps on checking its current state and updating responsibly. So first you're going to be making 3 containers to get the acceleration, gyroscope and temperature values from the sensor. So AG and temp are the 3 containers that are created for acceleration, gyroscope. Okay, so now we are using this get event to get all these values, that is acceleration, gyroscope and temperature values from the sensor. Okay, so next we have to calculate the total acceleration that the tracker experiences. So for that we are going to be using Pythagoras theorem. So here we have set out the total acceleration value, which is the actual square root of, that is ax square or y square plus az square. Next, what we are going to be doing is we'll be checking if the total acceleration is actually baseline gravity. That is, we are going to be subtracting the total acceleration from the baseline gravity to get final acceleration value. Setting up another variable, that is the current time Okay, so after setting up the current variable, we will move on and be checking if it's physical mode or not. Okay, so here this is just represent a basic function, and then for checking physical movement is present or not, we'll be using if statements. Okay, so first if statement would check the acceleration, that is axial delta, that is the absolute value of total acceleration minus the baseline gravity is greater than the motion threshold, that we had actually set it to 0.35. If it is greater than the motion threshold, we will have to update this variable. And then we will also have to update the last motion detector time. Okay, so we are going to be updating the last motion detector time to the current time. Okay, so suppose if statement is not true, then we would have to have a statement which actually suggests check if the difference in time between the current time to time is set it to 2 seconds. So if it's greater, you have to report that it's moving as follows. Okay, so after we have gone through this moving variable, that is we went through the case where the acceleration delta would be greater than the motion threshold, then in that case we would set is moving is equal to true and the last motion trip time to current time. Else we would check another case if the current time subtracted from the last motion again set is moving is equal to false. Next we will move on to the state machine transitions. Here we would look at the three cases that are possible. Okay, so the first case that we'll be looking at is it was rest now, but has just recently started moving. the target has just started moving, is moving, but tracking active would be false. So what we have to do is make the required changes for that. Since target has just started moving, it is moving to be true, and tracking active false. So for that, you have tracking to true. Then we will be predicting motion capture. So here we are using also this helpful function send mock LoRa payload, and in that we will be describing it as target started moving for this case. And we will be describing the last GB send time to be equal to the current time. So this should mark the end of the first case. Now we look at the second case. Okay, so case 2 include that situation that target was actually in motion and still in motion. So for that case, we will notice that is moving as well as tracking the true. Back to the second option suitably. Okay, then we are going to have to check the current time subtracted from the last GPC interval. That is the 10-second interval. We will have to display the current coordinate again. If this is the time interval, that is seconds, we are going to apply the map latitude and longitude. So, we just do map lat. That's equal to actually just add a value and then move to the original map plus any value. Set it to 0.5 something. Okay, so after we updated the mock model, we use them because we don't have a GPS module. So I set it to 0.5 and 0.07. Also to display in motion. Then I've also updated the last GPS time equal to the current time. Now moving on to last case. Case 3 would include that situation where the action was active and the object was moving but has no stop. Okay, so in the last case, is moving would be false, but tracking would still be active. So for this case, we would have to make the required changes. Okay, so since in this case is moving would be false and tracking active would be true, we have made the required change that we said send mock load payload would be displayed as target stopped, and we are going to print the session as completed and we are entering be false since it was originally true and we completed the then we introduce a delay of 100 milliseconds in the total void loop so that it would run without any issues or errors. variables segment, then you're going to look for variable state. So what we're going to do is all the axes that we have written, it's going to be printing target starting, it's going to be printing in motion, and context is going to be printing target stop, and then it will also printing that is will get a GPS is in part, and it will be up to I don't think we need up to 4 decimal places. You can do up to 2 decimal places. So we can add the model will add from Mongo also. The two is for another decimal places that we want to show in the administrative dashboard, and we have it was north and east for the long width and longitudes. Okay, so essentially this is the entire code. You can put it up if you have any. I can also mention which part I should go through once again to explain. Okay, so I see you asking that why if we check current time and large GPS temperature equal to case 3. So case 3 is mainly for the being part has now stopped. So which means it's false, but backing up and we will look at keep on going, but it is in motion. So essentially after 2 seconds, the part is not moving. So we would just need backing up to 2%. Okay, yeah, actually we just use the adaptive library. So we use that actually to create this virtual object that will tell you that the sensor values, the acceleration, the temperature values also. And okay, let's last part again. So this cell payload is essentially just error. So I described it over here at the beginning in case one. So what the function does is it just gets a string that I will translate it as the input, and it depends on what happens. This was true, this was executed, and this was true, this would have been executed. The one that had the following strings body. So in state, it is referred to which block executed and what was the input of the function in that particular target start moving, and it would essentially print target start moving and rather these data. Okay, here the write out begin just initialize the I2C protocol. It sets 21 to T and 22 to SCL. Compile takes some time. So after compiles, I'll tell you guys what you face.
ఆప్షన్ లేకపోతే ఏం చేస్తావు? నేను జాయిన్ అవును బొంబాయి జాయిన్ అవుతాను. అస్సలు సో అమ్మ ఇంటర్న్షిప్ లో అట్లా ఆపకూడదు మనం. ఇంకా
Okay, guys, did you all compile? Just the play button. You can see the serial monitor here. Okay. Now what you can do is change any acceleration value. Okay. Now we will get motion event capture, and after every 10 seconds, yeah, you can see the again return audio. If I put this 0, yeah, it will show session complete, entering sleep mode.